Hello, everyone. I'm Charlie Lewis. I'm currently the prototyping lead for Cyber Reboot at IQT Labs. And today I'm going to walk through an open source project called Poseidon, which you may have heard of. And it's built around the idea that we can use software-defined networking and machine learning to not only have better situational awareness of what's on our network, but also start taking automated action based on that insight. So let's jump right into it. Too often the norm as defenders is that we're tasked with incident response and remediation after an attacker has been detected and likely already succeeded in their objective. I want to talk about proactively detecting that abnormal behavior inside a network while it's happening and be able to better understand what those devices are actually doing. So in order to do that, we really have to answer 3 questions about everything on the network, not just the things that we think are on the network. First and foremost, what is on my network and what is the role it plays? I don't mean just like there's a Windows box or a Linux box over here. I'm talking about like what's the actual purpose of that device? Is it a developer's laptop? Is it an Active Directory controller? Is it a file server? What's the role of those devices? Once we have a grasp on that, we want to be able to discern if those devices are behaving in a way we would expect them to behave based on that role. So a developer's laptop or Active Directory controller or a file server, are they behaving in respective to each of their own roles? And behavior is not just Boolean across the board. It's kind of the expected communications for the role they've been classified in. So a printer that's no longer serving print jobs and instead is serving up SSH, that's no longer the behavior you expect for that role. But it's important to remember that neither serving up print jobs or SSH sessions in themselves are neither normal or abnormal behavior. It depends on the context. Which brings me to the third question we have to ask ourselves is, do we actually care? Do we care about that abnormal behavior for the role it's been classified into? Do we care if it happens at 3 a.m. or on a Sunday? And perhaps certain roles we care more about than others. If my AD controller starts acting like something else, I probably care more than if, rogue developer laptop is doing something weird. So we started writing Poseidon about 3 years ago to see if we could start answering those questions. And we wanted to do it for everything on the network in an automated way. And we kind of asserted that the 2 key enablers to do this, as I mentioned, are SDN and machine learning. So today we're going to go on an adventure and see if I can make a demo actually work. Had some struggles in the past, so we'll see where we go. First, we're going to go ahead and actually build an SDN network using Faucet. Then we're going to install Poseidon and connect that up to Faucet. Then we're going to talk about events and using Faucet's events with Poseidon to be able to learn about the things in your network. Then we're going to attach, I've got 2 Raspberry Pis here that are just running pretty vanilla Ubuntu and are set to basically start browsing random websites. So, your typical developer workstation behavior. And then we're going to set up some automated rules that will kind of define ACLs on the network. We're going to show those 2 devices being learned and analyzed. And then we're going to reapply dynamic ACLs based on the roles and behaviors that they get assigned. In theory, we'll see where we get. All right, so first off, this is just kind of a basic Faucet config, but let's go ahead and write a real one for our network. And I'm going to wire up a couple things. So I've got an Allied Talasys X230 here, and somewhere I have, yes, this is my replayed wireless to internet. I'm just going to put on port 7 for kicks. And then I've got a couple other Ethernet dongles here. This one's going to become our control plane, which I've pre-configured the switch for port 8 to be separated from everything else. So OpenFlow is only going to control ports 1 through 7. And then I'm just going to add, actually, I'm not going to add that one yet. All right, so we'll just start with that. All right, so I'm going to open up my Faucet config. Maybe. All right, so we've got nothing. Great. So I'm just going to add a VLAN, give it a name, give it an ID, and I'm going to add a Faucet VIP here so that I can do layer 3 routing. And I happen to know what network it's going to be on already, so fingers crossed that works. Oh, is it cut off? I'm sorry. Okay, and then I'm going to add my data path. We'll just name that X230. And insert a MAC, which I've pre-configured that switch to just be 2 for simplicity, because I don't want to type it out. And I'm just telling Faucet what the hardware it is. And then I'm just going to define my interfaces. And those are going to each be on the VLAN that I just created. And then, as I said, we're not going to actually, there's 8 ports, but we're just going to configure 7 of them because the 8th one is my control plane. And that's all we need to do for that. I've already pulled down the source code for Faucet. There's lots of ways you can run this. I like to run it in Docker containers, so I'm just going to do a Docker compose up. Faucet pre-built this, so it's going to be faster than if you're doing it from scratch. All right, so those are up and running. And if I just look at the logs, you got stuff. Seems to be happy. Cool. All right, so now that we've got that up and running, let's take a minute here to just kind of talk about what Poseidon actually is. So it's an application that leverages SDN, specifically Faucet, also supports Big Switch, but for what it's worth. But the idea is that it can collect network traffic, feed it to machine learning algorithms, so those devices can be classified into roles and their behaviors, and then based on those results, Poseidon then reapplies action by updating the posture of that network relative to those devices. So let's go ahead and get Poseidon up and running. I've also pulled down the source code for that. And I've also pre-built a Debian package for it, but you can go hook it up to our published one out there or build it yourself. And that's going to go do some stuff. All right, while that's installing, I'm going to add my mirror port. So as I said, that Poseidon wants to capture traffic so we can learn about it. So I'm going to have a predefined port of 1. And that's just another Ethernet dongle that's attached to the same laptop that we're running this all on. Oh, that just got an IP. That's weird. All right. All right, so let's talk about how Poseidon learns about what's in the network. So it uses modules, as we call them. And one of those is Network ML, which is the piece that does the machine learning for the classification and behavior or anomaly detection. We also use POF, which is doing fingerprinting of operating systems. And we also do additional metadata, such as MAC vendor lookups or reverse DNS. At this point, I'm going to actually add a couple devices to our network. So we've got these 2 network, Raspberry Pis that I will just give power to. And I'll go ahead and wire these up to port 385. All right, so how does Poseidon learn from the perspective of Faucet? So it uses Faucet's event socket. But before we get to the event socket, let's take a step back and look at how we originally tried to do this before there was a Faucet event socket. And we did that by parsing the log files that we just looked at. This is bad. Formats change. It's really brittle. we ran into lots of issues with that. In fact, I think it's broken currently. So getting from parsing log files, we decided to kind of think about a better way. And I think I talked to Josh and Brad about this actually at the last FaucetCon 2 years ago. And Josh came up with, well, there's a couple of pieces to this. One, so just under 2 years ago, there was a PR that got merged to allow reloading the configuration without having to restart Faucet. So if I'm going to be changing things, I don't want to have to like restart everything every time. And then that in conjunction with the event socket. So I get things, this is merged again December. So I guess it's like, what, 2 months after the conference. And this is kind of experimental, give it a try. Then 2 days later, after I tried it out and I was like, this is awesome, I was like, now I want to be able to send those messages to some other thing so that I can make use of those events and then change the config without having to restart things. So I added a adapter for RabbitMQ, which is just a message bus, to take those events and send them out as messages to some other service to consume. A couple months later, I then took that and built it into Poseidon so that it could consume those messages and do something with them. And then about a year later, I convinced the Faucet team to promote this out of experimental since we've been having such good luck with it. So that's kind of how we got away from parsing logs and terrible things. And now we can consume much more machine happy objects in JSON format. So you can actually just use netcat attached to the socket, and you'll get these messages out if you enable the environment variable for Faucet to use the event socket. Just a prettier version so you can kind of see what's happening. This is an L2 learn event, and you can see like which port it's on, VLAN, MAC addresses, and IP addresses if it has them. And there's tons of different types of events, but for what Poseidon's currently doing, it takes most advantage of L2 learn events. So what does it look like from the Faucet side, or sorry, the RabbitMQ side? So after it's getting sent on that event socket, the RabbitMQ adapter pushes these out again as messages that can be consumed on different streams if you wanted. Like, so this is just a Faucet.event, but you could imagine slicing and dicing this to things that your particular consumer cares about. All right, so now that we've gotten events into Poseidon through RabbitMQ and the event socket, how do we take automated action against that? Well, there's two parts to that. One, Poseidon will actually rewrite the config. And two, there's a YAML file that we've added, which will let you basically define changing ACLs on the fly. So this is just a set of rules, and for each rule name, you can have multiple rules underneath that. And for each of those, there's a key pair that it matches on to say, like, if the operating system matches this, or if the role matches that, or if the behavior is like this, then apply these list of ACLs, which can be n number of them. So let's go ahead and see. Okay, our install is done for Poseidon. Great. There's a couple things we want to do. We want to actually update to enable that automated ACLs for Poseidon. Out of the box, I don't enable it because it's might do things you don't expect. Oh, that's not good. One sec. All right, so there's a flag here for the configuration to enable automated ACLs. I'm just going to change this to true. And then I'm going to rewrite so there's a default rules YAML that it comes with. I'm just going to rewrite this to one that's applicable to our setup. If I give it rights to do that. All right, so I'm not connected to any Macs on stage, so I'm going to change it to Linux. Oh, actually, before I do this, let me pull up my. So I have a pre-configured ACLs file that Faucet knows how to read. There's nothing specific to Poseidon for that piece. And I didn't want to write this on stage, so I pre-populated these. So I just have one that's called protect me, and it drops everything from HTTP and HTTPS, and then allows everything else. Scary IPv6 blocks IPv6 and allows everything else. And scary mail blocks SMTP with SSL because mail can be scary. And then I have a no internal one that I'm actually not going to use, but Ryan will talk about that in his next talk. All right, so those are our named ACLs, and this is where we can use those. So I'm going to use, I don't know, protect me for this one, and we'll say scary IPv6. By the way, IPv6 is not that scary, but some people are afraid of it. I also don't have a printer, so I'm going to use developer workstation, which is what we're trying to emulate here. And we'll use scary mail because developers definitely are afraid of mail. And I don't think I'm going to get abnormal behavior, so I'm going to change this to normal just so we can see it happen. And we'll use protect me again. So what this is doing is if we get a device that gets behavior of normal, it will trigger this rule and apply protect me ACL. And on the flip side, if we get a device that's both classified as a developer workstation role and an operating system of Linux, then it will apply scary mail, protect me, and scary IPv6. Yes, yes. But the named ACLs it's using from Faucet ACLs. All right, so now that we've got that, we can go ahead and there's a nice little helper script that we've included in Poseidon, which will start Poseidon and Faucet and do all the configuration to make them happy with each other. I do, and I will. Thank you. All right, so there's a run script that'll run. So it's stopping the Faucet that I already had started up, and it will start it up again with the environment variables it needs, such as automatic reloading and the event socket, things like that. Maybe it will finish. Okay, good. All right, so while that's coming up, I'm going to actually update the Faucet config, as Josh mentioned. And there's two things we want to do. So remember, port 1 is my mirror port, so I want to change that to not be a native VLAN. And instead, we give it a description so we know what it is. And I'm just going to do output only is true. And then we want those ACL files that we just, or ACLs in that ACLs file to be included so that Faucet knows where they are. So I'm just going to add include ACLs YAML. Okay, so let's see where things are at. All right, so there's a container event here. That's kind of the orchestrator for starting up Poseidon. So it's still determining all the components it needs, building them, and starting them. So that's going to take a minute or two. While that's going, I should be able to look at the Faucet log file for my two devices that I plugged in. Actually have a slightly experimental fork of Faucet that Josh helped me with to get ARP. So that I know what IPs those things are at. So 253 is my Faucet VIP. So I've got 80, 217, which is somehow my mirror port got an IP, but we'll just ignore that for the moment. So definitely got 80 and 240 are my two Raspberry Pis in theory. So let's try ahead and SSH into those. It's very busy downloading the internet. Okay. And then just to prove that the ACLs are not currently applied, I can do things like telnet to an SMTP server. Works. I would hope so, being that we're at Google. And I should also be able to get to that from HTTP. Oh, or not. Interesting. Oh, yeah. Sorry. Just kidding. Yes. Telling it too much information. Thank you for the help. And 443 should also work. Cool. So those are the rules we were applying. And I'm not going to bother with IPv6 right now. But anyway, so that just shows that's working. Let's see while we're reading. Okay, so event spun up all these containers while we were doing that. And the very top here, you see Poseidon's running. And then it's actually also started to capture containers, which is actually doing a TCP dump of the mirrored traffic from Faucet. So if I look at my Faucet config again, it should have changed. You'll see here port 1 is now mirroring port 5 and port 3, which are the two we just plugged that Raspberry Pi into.
So Poseidon did that on its own.
Yes.
Poseidon's like, oh, I see this port is up.
So yeah, so Faucet said, hey, I have these two new devices, and then passes that to the RabbitMQ. Poseidon picks it up and says, I don't know anything about those two devices. Give me traffic from those. And then it updates the config. Yes. All right. And so normally those captures would run 15 minutes, but I don't have that much time on stage, so I had them set for 3 minutes. So while that's running, I can actually show you there's a kind of CLI we've added with Poseidon. So I can do Poseidon shell. And I can do show all. And this shows me what it knows. So actually, that's kind of funny. All right, so the bottom two, you can see the Ethernet vendor is Raspberry. So that matches up, which is good. The top one that says Apple is kind of funny because I'm running a Dell, but I do have an Apple Ethernet adapter. So it's actually doing what it's supposed to do, which is great. And you can see currently we don't have any data for POF or Network ML because those are modules that are still running after the data is collected. While that's running, I'm going to go ahead and pull up Grafana. So that little helper script that I've used also packages up Grafana and Prometheus so that both Poseidon and Faucet can use them. And then it preloads dashboards. So this is the Poseidon stats one. Got 1.5 hosts. I don't know what that means. Gauges are weird. And you can see not much else is happening. But you can see, well, that's really small. But there's two things that are mirroring. There's one thing that's queued, 3 things that are unknown. And this will kind of just update as things happen. If I look at my Faucet instrumentation, there is a nice graph down here of config reload requests. So I think, yeah, so the leftmost one is total config reloads. And then the middle one is cold, which means it like has to dump everything and run everything again, which we only did one time, which is probably when I told it to restart using my helper script. And then everything else is a warm reload, meaning that it can kind of retain a lot of the state that it already knows and just change pieces that it has to. And this has been up for a few minutes, and we've already done 8 or 9 configuration changes. I've run this in events that our company has hosted with a couple hundred devices over a span of 2 to 3 days, and it does about 3,000 to 5,000 configuration changes without affecting connectivity of the network or impacting end users that we know of. They didn't come complain, at least. All right, so okay, so if I update this, you can see POF ran. It now knows those things. Those two things are Linux, and I'm guessing that the machine learning stuff is still running. Oh, not finished. I want to see real quick if we got any more changes. Oh, so the mirror is finished. Poseidon changed it back and is no longer mirroring port 3 and 5. And all right, so it's kind of a, you don't know what it's going to do. So it's not necessarily going to be able to classify the role because it may not have enough information. Again, I shortened the capture to 3 minutes. It should be 15. So it's possible that it's not going to actually be able to determine that these are my fake developer workstations, which means that those automated ACLs probably won't get applied. But everything else seems to be working, so that's good. All right, so what did we accomplish? Well, we got the SDN network working. We received events from RabbitMQ. We automatically mirrored traffic. We didn't quite get the machine learning bit, but it's kind of understandable considering we didn't let it capture very much traffic. But we did, well, we didn't actually do anything from ACLs because it didn't know what it learned. But we did update that configuration because you can see that it is automatically changing that and applying that. How can we make this better? Probably several ways. I've come up with a few. One, Faucet agent. So right now I'm directly writing to that config file, which is fine if I'm the only one doing that. But what if there's some other application that also wants to do that? Then we've got to figure out like who changed what, who pulled from when. Faucet agent's kind of that intermediate of if I send it to it and it applies it, I'm good. And that's what all the other applications that want to do that should use that single point of entry. But it's still early days. Second, currently Poseidon only uses L2 learn events and L2 expire events. I would like to expand that to more interesting things like topology changes or ports that went away or configuration changes that it's not aware of. Another thing you notice I was always kind of stuck in Etsy, Faucet, YAML. That's because Poseidon doesn't know how to deal with other config files that are included directly. I'd like to improve that. And while it mostly worked on stage without too much difficulty, this has had historically lots of deployment challenges and configuration issues. So I'd like to make that a little bit easier. And finally, so these top 4 are kind of the components we use and have written as our team for Poseidon, and they're all open source. The middle group are projects that we rely on, critical to making this work. So thank you for that. And the last 3 are ones I used to make this presentation. With that, any questions? Oh, and I'm at time, so you can kick me off stage or questions.
So how was Poseidon training set?
Yeah, so we actually collected on our own internal network to kind of bootstrap that, which is why we have silly things like developer workstation, because that's kind of amorphous. I don't think that's necessarily applicable across the board. I don't think all developers are created equal, and that is one of our challenges. So we're not entirely sure that the classifications that we've trained are transferable or ready for real world stuff. Other questions?
I think it's interesting that you kind of front-ended the sampling. There are 2 things about that. One is that, does that mean that you sort of kind of permissive permissive kind of apples and networking, observe the behavior to be able to classify things. And also, how do you evolve that over time? Where maybe I connect to the thing and then go out for lunch for an hour or something and come back. Or maybe somebody's or devices. How do you detect a change in a device's behavior?
There's a lot to unpack there. So first, the main change that Poseidon will make to your configuration is being able to mirror. So just being able to get a copy of the traffic, not necessarily like change other aspects of the configuration. The second piece of that is that ACL's definition file that I was showing, and that will actually change the behavior. But that is defined by ACLs that are already known by Faucet. So it's not like I could just go make up something. So you could delineate those roles if you wanted to. The second half of your question, what was that again?
Okay. All right, probably that's too much. One is that I guess the question is that if you block every quarantine, then you perhaps can't observe the behavior. Whereas conversely, if you let them do too much, then you're eventually letting them.
Yeah.
And then the other thing is, how do you update somebody's roles? Maybe it changes.
Yeah. Okay. So detecting changes. Poseidon has a reinvestigation routine after it's learned everything it's heard about, and then it's just sitting idle. It will start reinvestigating things to see if they're still what it thought it was last time, and it keeps a history of all those changes. And then for determining like how do you know when to like quarantine or continue letting them do whatever they're doing, that's an open question. I don't have the answer for that.
You kind of already answered it, but the ACLs, are you building them on?
So the ACLs are predefined, but again, it's doing Faucet configure loads, so you could change them on the fly. And then the rules YAML that's defined for Poseidon side is also dynamic on the fly. So I can change both of those without restarting anything.
So the primary change also strikes me. You're right, faucets config. Would it be better to have a side channel? Yes, I could roll out
I mean, if I had my way, I think that's where Faucet agent would fit. But I don't make the decisions on where that's going. So, but yeah, I agree. I don't just changing willy nilly and doing God knows what is scary.
That's what Poseidon. So you apply style.
you're making, you said in the example you made on 3,000 to 5,000 changes in a couple of days or whatever. So, what is the administrator's reaction to so many? Let's assume that I had one bad actor and that actually changed. How do you know that so many changes are just because of the rate of change that is really happening? Very hard to figure out. And also, how do we know that the change itself, like, it's the most appropriate?
So full disclosure for those events, we did not do any ACL changes. It was just mirroring, unmirroring, capturing, and telling you what it knew, but not actually acting on that. So that was kind of how we got around the administrator side of that, of what happens if you start blocking end users that need to do stuff. This is more of we show it's possible. I'm not saying we have the right words to convince people to try it. All right. Yeah. You find me at the breaks. I'm happy to chat more. Yeah.